All right, let's switch gears and tell you about one Montreal professor's role in NASA's new telescope. NASA announced that its new James Webb telescope will launch on December 22nd. It is the most complex telescope ever built, and a team from Université de Montréal took part in its creation. With more on this, we go to Rene Doyon, Université de Montréal astronomy professor and head of the UdeM team. Rene, welcome to the show.
Good morning.
It's great to talk to you here. You know, I love my space. I love space. We're big space nuts here on the program.
Great.
So tell me, what sets this telescope apart from other telescopes that we probably have heard of? Like, top of mind to me is the Hubble telescope. What sets this telescope apart?
Yeah, that's a good reference. So Hubble is the reference. So basically, Hubble was a telescope sensitive to visible light, right? The light that you can see. But Webb will operate mostly in the infrared. In fact, beyond the red part of the spectrum, and that changed a lot of things. And the other thing is that Webb is much bigger than Hubble. It's 6.5 meter as opposed to 2.4 for Hubble. And also, Webb will be launched way far away from Earth. Hubble is 500 kilometers from Earth, whereas Webb will be launched 1.5 million kilometers away. It will always be in the shadow of the sun. That's very important. The telescope will be kept very, very cold, minus 233 Celsius. This is how we need to do infrared astronomy.
So the fact that it's so far away and you can get it so cold, how does it make the astronomy better? How does it help you discover more about the universe?
Well, it's to do with the scientific missions. There's many things the Webb will do, but one big mission is to find the very first galaxies that lit up, we think, a few hundred million years after the Big Bang. We know that the universe is 13.7 billion years now, and Hubble was able to see quite far, about 500 million years after the Big Bang, or 700, but we haven't quite seen the very first galaxies that fired up at the beginning, and the reason is that these galaxies, when they form, they have lots of massive stars and they emit a lot in the ultraviolet part of the spectrum. And because of the expansion of the universe, we live in an expanding universe. The lights, which are, you can think of them as wavelength and waves, and these waves are stretched and with the expansion of the universe, and they move in the visible and ultimately into the infrared. So you could have the largest possible optical telescope, you would not see this galaxy. You really need to observe at infrared wavelength. Another important reason is to study exoplanet atmospheres, planets outside our own solar system. We've now identified, more than 4,000 of those, and a handful of those that are right in the habitable zone. There's regions close to a star where you can find liquid water, and Webb will be able to probe the atmosphere, and in particular the Canadian instrument.
With Rene Doyon. He's an astronomy professor at Université de Montréal. He leads a team at the university that took part in the creation of the James Webb telescope that's launching on December 22nd. So, Rene, how'd you get involved in this NASA project?
Well, first of all, it was back in 20 years ago when NASA was trying to get involved with other partners, the Canadian Space Agency, and the European Space Agency. And at that time, there was no Canadian instrument. We had one component, which is the fine guidance sensor, and it was basically it's because my expertise in infrared astronomy, which really started off here in Quebec at Mont Mégantic Observatory, and so NASA researchers turned to us basically in terms to Canada. Knowing that there was really in Quebec that we had expertise at this. So that's how I got started. It was back in November 2001, so that's my 20th anniversary of involvement.
Oh, wow, that must be really rewarding to see all of that work paying off in this way.
Absolutely. It's big. It's been a big teamwork. I mean, Canada, the Canadian Space Agency. It's going to be a historic moment in the whole history of the Canadian Space Agency. There's never been such a huge projects, such a science missions of this scale. It's unprecedented. And of course, we also needed industry, high-tech industry, all the universities. So it's a big teamwork.
And you mentioned you're going to be looking at atmospheres of these planets in these habitable zones, ones that you can look at with this telescope. And correct me if I'm wrong here, the atmospheres, looking at the atmospheres are really important, because if you can tell what's in those atmospheres, you could maybe answer some questions as to whether there's life or not.
Exactly. That's the big step we need to go forward to in this ultimate goal of finding life. We need to detect their atmospheres, and for example, here on Earth, the oxygen that we breathe are produced by life, by photosynthesis, plants, and we can detect that remotely by looking at a very special class of exoplanet, those that happens to transit their star. So from our perspective, we see the planet going in front of the star, and you can measure a little dip in the light. But there's a little sliver of atmosphere from which the light for the star is filtered, and we can actually measure that very precisely. We need a big telescope, and we need special techniques to do it. And we've started to do that, in fact, with Hubble. In fact, one of my colleagues here at the University of Montreal, Björn Bennecke, made a major discovery 2 years ago. He actually found water in a habitable planet. Wow. It's not a rocky planet. It's a mini Neptune, but still, that's a major step forward. But Webb will be much more powerful to do this kind of work, and in particular to look at rocky planets. And we have candidates. Our instrument will look at these objects in priority.
The launch is December 22nd. When does the James Webb Telescope become operational?
Okay, so there will be about a 6-month period because we need to cool down the telescope, and we need to send the telescope. It's going to take 14 days to deploy the telescope. It's a very complex operation. The telescope is so big that it has to be folded like a big origami figure in the Ariane 5 rocket, and 14 days to deploy, and then another 14 days to go to the what we call the second Lagrange point. It's 1.5 million kilometers away, and then the telescope will cool down. It's going to take about 3 months. And then we're going to do lots of tests, aligning the mirrors. The mirror is made of 18 segments, and all that has to be aligned very accurately. In fact, the Canadian instrument will be absolutely critical for that operation. And about the 5th month, and all science instruments will be turned on, and I'm going to be in Baltimore, where that's the headquarters for the operation of the telescope to test that everything is fine. And then the first light should come around in June, roughly.
Wow. Oh, well, Rene, listen, we're going to be watching this. We're very interested to see the progress and what comes out, the research and the discoveries thanks to the James Webb Telescope. Rene, we have to wrap up, but whenever we have a space guest, a NASA-related guest, telescope guest, astronomer guest, we have to ask this question. What is your favorite Star Trek show? Which is your favorite Star Trek?
Oh, the very first Star Trek, the old one is my favorite.
William Shatner, the William Shatner original.
William, yeah, of course.
We will accept that answer, Rene. That is a good answer. Rene, thanks so much.
My pleasure.
Rene Doyon is an astronomy professor at Université de Montréal, leading the team from that university, taking part in the creation of the James Webb Telescope.